Hello guys, so in this video we're going to discuss the part B of homework 4. So here it was asked to derive Broaden's Jacobian update as the minimum Frobenius norm update constrained by the second condition. Okay, so we're going to get the Broaden's equation which we proved in the last part, but this time using the minimum Frobenius norm update which was constrained, which will be constrained by the second condition. So let's get started. Okay, this one we already discussed in the part 1, part B. So let's go to the part 2 or part B. So let me write this part B. Okay, so as we know, we proved this part, jk plus 1 is equal to jk plus uv transpose. Okay, you are taking some vectors u and v transpose, and let's take this as equation 1 and equation 2. This we have already proved, which is defined by let's take f of k plus 1 equal to f of k plus j of k plus 1. This is the updated Jacobian into, let's write d instead of writing like k plus 1 minus xk, which is also derived already. Let's take it as k, I'm sorry, as d. Okay, let's take it as d, and we can also write this as delta f is equal to jk plus 1 into d. Okay, this is the equation 2 and equation 1. Let me show you what are u and v. U and v are nothing but column vectors. U where u defined as, it looks like v. My apologies. Yeah, this is u, u1, u2, u3. Similarly, v1 is a column vector, v is a column vector with the components v1, v2 and v3. Okay, if you take v transpose, it will become a row vector v1, v2, v3, and the multiplication of this is 1 cross 3 means, okay, sorry, it's 3 rows 1 column, 3 cross 1. This is 1 row 3 columns. If you do matrix multiplication of u and v transpose, you will get 3 cross 3 vector, 3 cross 3 matrix, which will be u1 v1, u2 u1 v1, u1 v2, u1 v3, u1 v3. Similarly, u2 v1, u2 v2, u2 v3, u3 v1, u3 v2 and u3 v3. Okay, gotten 3 by 3 matrix over here. Now let's get into this. So now here what we're going to do, our motive is the Frobenius minimum, where we're going to take, okay, we want to minimize this, and as you know, to minimize any function we need to take the partial derivative of that with respect to the independent variable something, for example x here. I'm just taking example, and make it is equal to 0. So we'll get them to minimize that. This is the basics. Now what you want to do, this we know, you can just equation from, you can say like this, jk plus 1 minus jk is equal to uv transpose. So you can just write like this, uv transpose magnitude square, both are equal. So we'll be doing the minimum of this, and this you can write as uv transpose in the form of summations. You can write like this, summation, double summation of summation of I, summation of j, ui vg. Okay, this is equal, this is a similar to this. Okay, we just am writing in a summation form. Now before doing this we need to convert u into in terms of v, so it will be easy. When while doing the partial derivative there will be only one independent variable, so you can just need to take the partial derivative with respect to that variable. So let's convert u in terms of v. To do that we'll be using equation 1 and 2. So as you can see here, in equation 2 we have the value of jk plus 1. Okay, so we'll use the value of jk plus 1, this term, and put it over here, and we'll solve for v u in terms of v. So let's do it. So delta f will be equal to, in place of jk plus 1 it will be jk plus uv transpose into d. Okay, I just did put this value in here in place of jk plus 1. So if you just expand this, f is equal to jk plus jk into d plus u v transpose into d. Now if you just want equation in terms of v, to get the value of u is equal to delta f minus jkd divided by uv d. Okay, so you got the value of u in terms of d. Now let's convert it into simpler form. Let's take this as h, some vector. So h divided by this, you can just write like in summation form, vi di. Okay, so we got the u in terms of v. Now we're going to use this here. So it will be u square, so h by summation of vi di whole square, and what is vt over here, vt, just keep vt as like that only. So you, okay, got it. You need to convert this into the summation form. Sorry, forgot that. Okay, so this will be equal to summation, if you take whole square of this, ei ji, it will be ui square vj square. Okay, now we'll just substitute the values, put these values, double summation ei ji. Okay, let me write it again properly. Summation of I, summation of j, ui square, because we are taking square, j square. Okay, now if you put the values, it will become summation of I, summation of j, summation of j ui squared. So it will become, h I squared divided by summation of I vi di squared whole squared. You can take this outside, then this vi squared. Okay, yeah, that's correct. Now what we're going to do, squared, right? Yeah, so these are two terms. Let's summation of I vi di whole squared, and this term ei ji, summation of I hi squared and vi squared, right? Now what we're going to do, we're going to take partial derivative of this. Okay, so let's take this as a function p. So we'll be doing d dou p by dou. With respect to v, we're going to take, let's take with respect to m some variable instead of I, to not get confused. So here we're going to do the chain rule. Chain rule means we'll take this, we'll keep this as constant, then we'll take derivative of this, plus keep this as constant, take derivative of this. So let's do it. I'll be writing over here and make it is equal to 0. Okay, so let's do it. So let's keep this as constant first. Summation of I vi di whole square as constant. Derivative of this would be summation of I, so hi square, vi square will be 2 vm vj, right? Yeah, this is j. It has to be j. Okay, sorry for my mistake. It has to be j because uivj, right? Okay, plus now we'll keep the numerator as constant, this term as constant. Ei summation I summation j hi squared vj squared multiplied by this. So as you know, derivative of the entire term, which is 1 by x square, for example, x square, derivative of this term would be how much? Minus 2 into x to the power minus 3, which is equal to minus 2 by x to the power 3. Okay, this we know as the basics. So this will be we'll take derivative of this with respect to the whole term will become minus 2 divided by summation of I vi di whole cube. Then we'll take derivative of only this term, where this will become 1 with respect to dx by dx is 1. Similarly, dv by dv is equal to 1, and only we're left with this term, so it will become dm. Now it is equal to 0. Let's take common terms out. So you can take this thing out, 2 is there, you can take this out, and you can also take the h square out, h square vm out. Okay, h square out. Okay, let's keep the vm because vm is not here. So if you take this thing out, vi di whole squared on the top, summation of I h squared, 2 you can take out, and this is not required. I think vj is not required because we've done the, so it's not required. H squared. Okay, so we'll be left with vm minus h square taken out, so we'll be left with summation of j vj square to dm divided by summation of I vi di, because we have taken the square term out, only one term is left, vi di. Okay, so we got this, which is equal to 0, and you can just see this and tell that this term cannot be 0, so we'll just cancel this term, and this term is equal to 0. So you can write like this: vm minus summation of j vj squared divided by summation of I vi di into dm is equal to 0. Let's take this term as a constant alpha. Okay, so vm minus alpha dm is equal to 0. So write this: vm is equal to alpha dm. Okay, so we got this. And if you just use the transpose term, like v transpose is equal to alpha t transpose, okay, which we won't use this. So we got the value of v transpose, we got the value of u. So let's put both the values in this equation number 1, and see what we are getting. So the equation number 1 is like j plus 1 equal to jk plus, it was u v transpose. Okay, so it is like jk, and jk plus 1 is equal to, what is the value of u we got is delta f. See, it is delta f minus jkd by v transpose t. Delta f minus jk into d by v transpose d. Just put the values of u and the value of vt is equal to alpha dt, alpha dt, and again you can put the value of vt over here. Jk plus 1 is equal to jk plus delta f minus jk d into alpha dt, means d transpose whole divided by v is alpha dt, again alpha dt into d. Okay, alpha got cancelled, and if you put the value of d is taken delta x, d into dt is equal to modulo square is equal to delta x square, modulo squared is the magnitude square of that thing. So you can just rewrite this as jk plus 1 is equal to jk plus delta f minus jk d means, let's rewrite it properly, jk delta x or to the power transpose, and this is modulo of delta x square. So this is the value we got. Let's compare it to the Broaden's equation from the Wikipedia to see whether I got the right answer or not. So as you can see, if you compare it, let me make it smaller so it will be visible. Okay, so as you can see, we got jn is equal to jn plus jn minus 1. They have taken jk plus 1 is equal to jn, you can say that jn, and this is jn minus 1 plus delta f minus jk is equal to jn minus 1 delta x to the transpose. That is, so we are able to prove this. So let's see what's there in the part 3. That's it for this video.